Okay, let's proceed to video number 6. Now, itong number 6 will be actually another topic. But since meron pa tayong dalawang problem na hindi pa nasusolve, so I will just discuss a little bit. Okay, so here, wait. Okay, dito, problem number 3, I will read. A reinforced concrete girder section will be subjected to the following basic service moments. So we have moment due to dead load 240, moment due to live load is 160, and moment due to wind is 125, and moment due to earthquake is 105. So there are 4 load types na. And number 1, determine the factor load combination if basic live load governs. Determine the factored load combination if wind load governs, and determine the factored load combination if seismic load governs. Now, actually, wala nakalagay dito kung anong NSCP, ano? So, that is NSCP 2001. So, yung 2015, may load combination din yun. Then, basta alam nyo na to, madali lang din naman yan kasi application lang. Okay, so for the solution, makikita nyo dito, for number 1, MU is equal to 1.4 of MDL plus 1.7 of MLL. So direct substitution lang naman ang given. 1.4 times 240 plus 1.7 times 160 is equal to 608. Then for number 2, MU will be 75% of the combination of dead load, live load, and wind load. So, yung live load should have, 1.7, and the wind load is 1.7. Then 1.4 for dead load, so this is 2001. Since magkakasama yung tatlo na yan, hindi natin pwedeng kunin yung 100% na yan, kaya we have to only take 75% niya. 0.75, okay, ito may dapat, may parenthesis, 1.4 times 2.4 plus 1.7 times 160 plus 1.7, 125, and we have the basic formula load combination MU equal to 615.375. But meron tayo doon ng another one formula that if full dead load is assumed, then we have MU will be equal to 0.9 of M dead load plus 1.3 wind. So wala yung live load yan. So that's only 378.5, and therefore hindi naman siya mag-burn. Mas malaki pa rin yung 615. Then for MU, considering earthquake, that is 1.4 dead load, 1.7 live load, and 1.87 earthquake. Then again, 75% lang naman yung kukunin natin dyan. Now, last time sinabi ko yung 1.87 is equal to 1.1 times 1.7. Yan. 1.87 yan. Kumbaga kasi yung 1.7 is for wind. Anong ibig sabihin niyan? 1.1% din yung relationship ng wind sa earthquake. Okay, so we have 603. So, ang magiging design moment natin will be the governing or the largest. Kasi load ito eh. So, 615 na. 615. Alin yan? Ito. Sa load combo number 2. Ngayon, pwede kayong magtanong, bakit hindi magkasama? Bakit hindi naging 4? Bakit hindi may dead load ka, may live load, may earthquake, at saka may wind? Anong gusto nyo? Dilobyo? Ibig sabihin, gabag yun may earthquake pa. Diba? Grabe naman yan. Kaya hindi yan pwede pagsabayin. Okay? So, application of formula lang. For number 4, a simply supported rectangular reinforced concrete beam has a span of 6 meters, width of 250 mm, effective depth of 500, and a total depth of 600 mm. The beam is reinforced with 325 mm bars. The concrete strength FC prime is 28 and the steel yields FY 415. In addition to the live load and its own weight, the beam carries a 150 mm thick concrete slab that is 5 meters wide. Okay, the unit weight of concrete is 24 kilonewton per cubic meter, and the beam is to be analyzed and designed using the strength design method. Okay, so number 1, compute the total service or unfactored uniform dead load acting on the beam, calculate the nominal moment capacity, and find the maximum uniform service or unfactored live load acting over the entire span that can be supported by the beam. Okay, ngayon yung illustration natin dito. So this is 600 by 250. And ito yung slab rib. Ito yan yung part nito. Okay, let's assume na nasa right side siya. So actually, parang hindi balance yung load So dapat meron din doon. So anyway, pagdating sa shear, kasi magkakaroon ito ng, kumbaga yung load natin concentrated dito, magkakaroon ito with respect to this beam, torsional effect. Yan. Pero pagdating sa shear na yan, pagdating sa shear and torsion, now, siyempre yung weight ng slab, kailangan i-consider natin as dead load, and magkakaroon din ito ng loads yan. Yan ang actual. So in theory of structures, it is taken up yung sa about load analysis na. So I hope alam nyo na yan. So that will be your weight. Now, yung naman, yung 24 kilonewton per cubic meter, galing lang yan sana. That is actually yung weight ng unit weight ng concrete is equal to 2.24 kilonewton per meter cubic meter, I should say. Then the specific gravity is 2.4. Then unit weight ng water is 9.81. So multiply natin yan. That is around 23.56, like rounded up. Kaya 2.4 na lang ginamit natin. Okay. So for the solution, ano ba yung first question? Compute the total live load acting on the beam. So total service uniform dead load pala. So kailangan, since yung given is yung mga superimposed dead load pa lang yan, hindi pa kasama yung weight ng slab, kaya kailangan natin compute. So we have plus yung weight ng beam so that is equal to 0.25 and 250 plus 0.6 times 24. So this is now the weight ng beam. Then plus 0.15 times 5 times 2.4. That is yung weight ng slab. And you'll get to 1.6. That is for number 1. And number 2, calculate the nominal moment capacity. Okay, so since galing na tayo dun sa mga example ka na sa mga former videos, dito sa given beam natin, kailangan alamin natin kung case 1 o case 2. Case 2. So by this video, it is assumed or I presume na alam nyo na kung ano yung mas madali. So rectangular beam yan, Then we can now use yung balance steel ratio for rectangular beam. Yan, makukuha nyo yung 0.0288. By the way, if ever na may mga discrepancies sa computation, what is important is for you to determine kung ano yung formula. So kung may mga mali man sa computation, that is not an issue this time. Ang importante lang yung concept kung paano isosolve na. So yung row actual natin, row actual ASBD is 0.0118, and kukompare natin, so na row actual is less than row balance. So ibig sabihin under reinforced siya. So hindi siya maabot sa row balance. So under reinforced, ibig sabihin mag-yield yan. Mag-yield yan, so you can use Fs equal to Fy. Okay. So ito naman, dumaan pa rin dun sa equilibrium for the purpose of solving for A. Kahit hindi na tayo mag-solve ng C kasi dito prove na na nag-yield. So kailangan natin yung A. Again, Fy na ang ginamit natin dyan. Kasi nga nag-yield. So A is equal to 102.712. And we can use now the couple. What couples? Baga mag-take tayo ng moment about the, kumbaga again, ito yung A. So dito yung centroid. Dito tayo kukuha ng moment sa level na to. So we have here T. A is Fy yan. Makuha natin is 274.183. Okay. Ngayon, pwede nyo naman gamitan ng ibang formula, yung mga derived formula. Number 3 is find the maximum uniform service load acting over the interspan that can be supported by the beam. Live load. Kagamit tayo ng load combo. So for simply supported beam, the maximum moment is WL squared over 8. Kahit sa strength, alam nyo na yan, di ba? So our requirement actually is here. PMN must be equal to MU. Okay, yan yung PMN equals MU. So yung safety requirement natin actually should be greater or equal. So if we have a simple beam, then siyempre andyan na yung live load and dead load. This is L. This is L. We have W here. Ngayon, pag-iwalayan na lang natin yung dead load and live load. That's why we have moment due to dead load will be equal to moment due to dead load will be equal to W dead load L squared over 8. Then moment due to live load will be equal to WL or LN times L squared over 8 also. So kailangan memorize nyo ito. So you will have 0.9 times 274.183 will be equal to 1.4 times 216. What is 221.6? So that is WDL times 6 squared over 8 plus the 1.7. So ito yung natin. Ngayon, ang fee natin na gagamitin is 0.9. Kasi 2001, wala na tayong problema dyan. Mag-yield o hindi. So, nag-check lang tayo ng yielding dito for the purpose of using WBFS. Itong Fy or 600 times D minus C over C. Basta huwag niyang kalimutan yan. and double live load will be equal to 14.47. Okay, now since gumamit tayo dito ng formula ng maximum moment, so simple beam, wait, okay, so for simple beam, kailangan alam niyo yung maximum moment natin. Meron tayong P L over 4. Meron din tayong moment maximum na WL squared over 8. Ngayon, kung hindi nyo alam, balik kayo dun sa shearing moment. Shearing moment. Ngayon, kapag cantilever, so madali lang naman yan. Kapag overhanging, okay, so, ang problema yan. But this is for determinate beams. Determinate beams, yeah. How about kapag indeterminate? Kapag indeterminate, so kailangan natin ng theory of structures. Indeterminate. But meron din naman ng mga hindi pa naman ganun laki ng degree of indeterminateness niya. So meron tayong fixed beam, fixed end beam, so meron tayong wrap, beam, then meron tayo talaga ng yung continuous beam. Kaya ginagamit natin yan mga methods, consistent deformation. So meron tayong 3-moment equation, meron tayong slope deflection method, meron tayong moment distribution, then kung talagang medyo gusto nyo mas magaling yung matrix theory of structures, so pero kaya naman yan by software. So, nowadays kailangan magaling kayo dito sa software. Okay, so ngayon kapag fixed end beam, meron tayong mga fixed end moment formula na. So may mga fixed end moment formula. Kaya fixed end moment formula. So if this W, you can draw this shearing moment diagram once kuha nyo lang yung reaction. Anyway, yung reaction naman is kalahati ng total load. So that will be WL over 2 pa rin. Okay. So ito, kaya nga Kaya lang yung moment diagram, meron tayong negative, meron positive, saka may negative. Kaya pag ganun siya. Pag ganun siya. And this is negative, or that is WL squared over 12. WL squared over 12. So, how about here? Yung moment maximum dyan. Dili lang naman yan kasi ibalik natin yung yung sa simple beam. This is WL squared over 8. So, yung moment dito maximum will simply be equal to WL squared over 8 minus WL squared over 12. And then you will get the value. Yan yung maximum moment yan. Or pwede ka naman share moment diagram. Okay, so may moment tayo dito. And kapag concentrated load ay A and B dito, so meron tayo yung formula na P PAB squared over L squared. Yung isa. Then meron yung P A squared B squared P over L squared. So I hope you are familiar with that moment distribution. Okay. Then meron pang iba dyan. So since tapos na kayo ng theory, I suppose meron naman na yung ginagamit ng integration. But here in RCD kasi kailangan natin gamitin dun sa pag-design ng 3-story na nag-iisipan ko pa kung nagre-require ba tayo o hindi dahil pandemic na. Pero kailangan yung matuto. Okay. So, meron ba tayo dyan ng dadaanan na pag-uusapan natin ito? Okay, so this will be our last video for the investigation of singly reinforced beam. Okay. Then we will now proceed to investigation of doubly reinforced rectangular beam. Okay.